Okay, this is problem number 9 on April 9th. Yeah, this is a pretty tricky problem. It's also one that's not going to be on the AP test, which is good news because of the alternating series. Usually we don't run into a problem like this. So notice it is an alternating series. So one of the things in our class, we learned that for an alternating series to converge, the only thing that has to be true is that the limit must be equal to 0. However, there was a catch to that we never really dealt with, and the catch was that the terms must be getting smaller and smaller and smaller and smaller. So notice, if you look at these terms, okay, they're definitely approaching 0, no doubt about it. However, notice we're jumping from 1/9 to 1/2, so it's getting bigger. Smaller, then bigger again. Smaller, then bigger again. So number 1 is false, because in order for the nth term test to work and say that an alternating series converges, the terms must be getting smaller, but they're not. It doesn't mean it's not converging, but I can't use the alternating series test, because in order to use the alternating series test, the terms have to be getting smaller and smaller and smaller. So then the next one says, okay, since they're not getting smaller and smaller and smaller, this is what this is saying, right? Absolute value. So forget about the signs. This is saying that they're not getting smaller and smaller and smaller, so it has to diverge. This one's saying it's not getting smaller and smaller, but it has to converge. So just because they're not getting smaller and smaller doesn't mean it doesn't converge, so we have to check it out. So what I did is I broke this up into 2. If you notice, I just took the positive pieces, 1/1/2, 1/4, 1/8, and then I took the negative pieces, -1/9, -1/25, -1/49. So both of these definitely converge, right? These are getting smaller. This is just a geometric series. This is not a geometric, but it's like a 1/n² type thing. And we know that 1/n², the p series converges. So this is the only one that's true because of that. Kind of a weird question. I wouldn't worry too much about that one.